Welcome back into example one. And in this video, we're going to extend this example a little bit. And we're actually not going to dig into additional solves in this video. But what I want to talk about in this video is along the lines of testing methodologies and what we think we can determine by digging into our outputs and what other solves that we can actually set up to try to answer the questions that we want to answer throughout the course of this analysis, right? So, we are trying to, the question here at the bottom of the screen, we're trying to construct a single bet strategy on this board. And we're trying to do so specifically against this type of opponent. Now, we've set up this game tree here to look at two different bet sizes. And what we would hope to see is that the solver might prefer one bet size over another. And that's kind of why I like to start at this macro to micro level that we talked about last video. Is if at the macro level, the solver preferred the large bet size far more frequently than the small bet size, or vice versa, well, we can start making some easy decisions then as to where we should kind of go with the next phase of our analysis. But as you can see here, there's a pretty even distribution between large bet size, small bet size, and check. So with all that being said, now we got to start thinking through how can we iterate and how can we set up other solves to build out tests that can lend us to finding an answer or finding a solution that we can start implementing in game. So what I've done here is I've built out a few solves that we can dig through here in our study template. So the first two are the ones that we're going to go through over the next few videos, which are this methodologies of, well, we've looked at the large bet size, we've looked at the small bet size in one solution. Now we're going to run two separate solves where we actually only use one bet size for each of the solves. So I'm going to run the same solve again, only using this large 75% bet sizing. And then we're going to run the same solve again in the following video after that and only look at this 33% bet size. What that does here is that by changing only one input, we're now going to start to see how the solver will construct those ranges differently. The thing that's important to understand about this type of analysis here is that the solver is going to work within the confines of the constraints that we actually provide it. What I mean by that here is there is a reasonable good answer at 75% bet sizing how a solver might construct an overall range. There's also a reasonable, decent answer that how the solver might construct a range at 33%. And there's probably a bunch of other bet sizes that we couldn't put into place to determine, well, what might that output look like? And you may actually ultimately find that expectation values are actually, they run somewhat close no matter what bet size that you actually pick. But what changes is the composition of how the solver allocates things into bets versus checks. That's kind of the next thing that we're going to look at here is, well, how does the solver iterate between large bet and small bet? And is there a difference here in our EV percentage and equity realization, as well as how the solver constructs the overall underlying ranges within each of those? We're then in module 5 going to start digging into some additional questions that we can start answering using node locking. Maybe we might say, well, what if we bet 100% of range, and how is the solver going to respond to that? Now that's going to involve us having to actually start locking components in range and locking some of those hands in the range, and we'll talk about that in module 5. Things like maybe the range assumptions that we gave into play were too wide. Maybe we want to test certain strategies, right? So we're going to start iterating and finding other tests that can help us tell a complete story, give us more observations all tied to how we can actually construct this single bet strategy on this board. And at the end of the day, that's going to help us yield some findings that we can then hopefully turn into heuristics and upgrade the way in which we might think about the game or think about this particular scenario. So I hope that all makes sense about this testing methodology. I hope that makes sense about kind of changing one variable at a time, running multiple solves. We're going to show you how we might do that through all of these different examples 1 through 4, and you'll see kind of how that process works over the course of these upcoming videos. So in the next part of this video, we're going to actually jump over to example 2, where we talk about the different tests that we might operate in that particular example. So I'll see you over there. So welcome back to example 2, and in this video, we're going to talk a little bit about the testing methodologies and how we are going to set up the rest of the tests that we plan to study. Now, the purpose of this particular example is to understand how we want to defend against an opponent who's going to continuation bet with 100% of range. And in this particular example, we're not going to be able to answer that question until we actually start node locking. And I'm not going to introduce node locking until module 5. But I do want to start showing some examples of some of the things that we can do within testing without node locking in this particular video. And I'm bringing out my Solver study template so we can kind of show you the different tests that I plan to run within this example. And what you're going to see in the next video, I mentioned here, if we kind of go back to this grid that we had, and as we were setting up this game tree in module 3, what I had mentioned was that the turn and river sizes, they don't necessarily matter as much. And I get asked that question all the time is, well, should I be a little bit more comprehensive in my turn and river sizes? Should I include multiple bet sizes on turns and rivers just to give the solver more option to give a more complete, more accurate tree? And certainly I would say if you are trying to implement a strategy where you yourself might be employing multiple bet sizes on those future streets, absolutely add those multiple bet sizes on the future streets, especially on the next street, right? So if you're studying the flop and let's say you have a strategy where you might bet a certain size on flops, but then on turns you might split into a choice of 1, 2, or even 3 different bet sizes, then yes, include those various bet size options on turns so that we can most accurately see how the range flows from one street to the next. But if you're only studying flop play and you're not necessarily working towards turns, it doesn't necessarily matter that much. It will change the EV somewhat, but the EV won't change very, very significantly from one street to the next. So what I wanted to do is actually, in the next video, I will share, I ran this solve with the rake as well too, but I also added more turn and more river sizings, just so how we can see the difference between the base scenario and the scenario where we kind of fill out the rest of the game tree a little bit more. In the final video within this particular module, I'm also going to run this solve without rake, just so that we can see how big of a factor rake actually can play in a solver output, and try to actually start thinking through some of the tests that you might want to implement in your own games, because a lot of us are playing at a casino and a lot of us are playing 1-3 and 2-5 at a casino where they're taking $8, $7 a hand, $6 a hand if we're lucky, and that can be a material portion of the board, and we don't necessarily want to be stuck in a spot where we don't understand how big of a factor rake can play, and some of the cusp hands that we might think that we can play profitably, now we actually can't play profitably in a raked environment. So we'll take a look at that rake solve and kind of compare it to the original base. Then in module 5, we're going to dive into some node locking, where we look at how we defend against an opponent who bets 100, We'll see how we defend against an opponent who bets 100 but bets a larger bet size. And then we're going to test out a check raise sizing option that we might want to make as an adjustment. And we'll look at that in Module 5 as well. Again, following that same methodology, we're going to run iterations of different solves by changing one input here and there, seeing how the output changes and comparing them back to our reference points. It's the same methodology that we're employing over and over again, but we're just applying them to different problems to be able to answer as many different types of questions as we can. So that does it for this video. In the next video, I'm going to jump into PioSolver, and we are going to look at examples 3 and 4 and just talk through the various tests that we might set up within those examples. So I'll see you over in Pio.